You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Amir Siraj. Amir studies astrophysics at Harvard University and is interested broadly in theoretical astrophysics. He is a Goldwater Scholar and US Presidential Scholar. He is co-president of Harvard Students for the Exploration and Development of Space and former senior US editor of the Harvard Political Review. His research advisor is Professor Abraham Loeb.
Amir Siraj, welcome to the program.
My pleasure.
Now, Amir, you've been the principal author of several papers lately that are certainly eye-catching, and one of them details that possibly, the sun having a companion early in its history that was lost, it's gone, might actually explain some aspects of the outer solar system as we see it. Could you give us an overview of that paper?
Of course. So I'm fascinated by peculiarities of the outer solar system, and one of these involves the Oort Cloud. So the Oort Cloud is a vast collection of icy bodies that spans thousands to hundreds of thousands times the distance between the Earth and the Sun. But unlike the rest of the solar system, which is a disk, the Oort Cloud is a sphere, and you can think of it as like if other stars like Alpha Centauri and others had Oort clouds, they would all sort of be touching and interlocking, filling space. So the inner edge of the Oort cloud is set by scattering by the giant planets, and the outer edge is set by the galactic tide. And the Oort cloud is really our reservoir that gives us these beautiful long-period comets that we see, and those are injected into the solar system by passing stars and also by fluctuations of the galactic tide. In addition, the Oort cloud may have played an influential role in shaping Earth's history, from potentially delivering water to, potentially playing a role in mass extinctions. Because the Oort cloud is so immense and distant, it's also difficult to study directly. The most successful approach to date has been to study the orbital and physical characteristics of long-period comets, and then to take these observations and to match them to some distribution of objects in the outer solar system that would give rise to the observed distribution of long-period comets. As a result, astronomers have been able to set constraints on the shape and the size of the Oort cloud. And simultaneously, theorists have been trying to come up with formation models that could explain how the Oort cloud formed as observed. And to be quite honest, this has proved quite challenging. In particular, models have encountered considerable difficulty in matching the observed ratio of objects between the outermost and the innermost parts of the Oort cloud. This is certainly true of the leading model, which proposes that the Oort cloud formed from the planetesimals that were scattered as a result of planetary migration in the solar system. And this model fails to explain why there are so many objects in the Oort cloud. So that is sort of the background on the Oort cloud. The other separate mystery that has been intriguing me is the origin of the proposed Planet 9. So the existence of Planet 9 was first proposed in 2016. And it was, an answer, a way to explain some peculiar orbits in the outer solar system. In particular, there were asymmetries in the distribution of trans-Neptunian objects, which are solar system bodies that cross the orbit of Neptune. And the idea here is that there's some unseen planet lurking more than 10 times from the sun than Neptune, with a mass of between 5 and 10 times that of the Earth. And this may be the best explanation for producing the observed orbits of these TNOs, these trans-Neptunian objects. Now, the search for Planet 9 has been on ever since and will certainly be aided by the Vera Rubin Observatory, which is expected to deliver the verdict on Planet 9's existence. But it will also evaluate alternative models such as, the idea that Planet 9 might be a black hole, or, maybe it's just a belt of planetesimals, or, even the possibility that the observed asymmetries in trans-Neptunian objects are just a statistical fluke. But if it exists, one of the central issues with Planet 9 will be explaining its origin. So to date, there have been 3 leading origin scenarios for Planet 9. One is in situ formation, second is scattering, and the third is capture. So the first, in situ formation, posits that Planet 9 formed at its current location, which is about 500 times the Earth's sun distance. And, while it may sound like a very simple, parsimonious explanation, the issue here is that the original disk of material from which the planets, the solar system, was formed was likely truncated much closer to the orbit of Neptune, which would make it nearly impossible to amass enough material to actually build a planet that massive at the distance of Planet 9. So the second scenario is scattering. And if Planet 9 formed, amongst the giant planets, amongst Jupiter, Saturn, Uranus, and Neptune, it could have been gravitationally kicked into a more distant orbit, at which point the influence of passing stars would have circularized its orbit. But the flaw with this model is that, it takes fine-tuning to get such an orbit, and there's actually a large likelihood that such a kick from a giant planet would result in Planet 9, leaving the solar system. Ejection is actually much more probable than, remaining bound. So the third scenario is capture. So either stealing Planet 9 from a passing planetary system, or, adopting one of the myriad free-floating planets that were ejected from their parent systems. And, this would be because there's a chaotic early period of planetary system formation during which we would expect planets to be ejected. But the issue with the capture scenario is, again, the likelihood of such an event occurring. You need a planet at just the right distance and just the right relative velocity in order to have a favorable chance at capture. Now, the sun spent its first 100 million years or so of its life in the birth cluster, which was a much denser stellar environment than the one that we live in today, which is called the field. And the birth cluster formed from the cloud of gas that produced the sun and its many siblings, and it, therefore consisted of a rich collection of stars and gas. And the high stellar density in the birth cluster means a high density of free-floating planetesimals, which were, of course, a byproducts of planetary system formation. And this would, improve the odds of capturing Planet 9 relative to the likelihood in the field. But papers have shown that even with the advantage, afforded by the birth cluster, this, boost in density, the likelihood of capture is only perhaps a few percent, which is comparable to the other origin scenarios. So we have these 2 great puzzles in the outer solar system. How did the Oort cloud form as observed? And also, if Planet 9 exists, how did it originate? And these questions have been in the back of my mind for a while. So, to give some background, in addition to, being a scientist, I'm also a classical musician, a pianist as well. And one of the advantages of this era of social distancing has been that I've been able to spend a great deal of of time, of this solitude, playing music and also thinking about science. And so I get to play through much more music than I would otherwise. And one day I found myself playing this wonderful fugue, which is a form of music that essentially relies on the interaction between several distinct voices, and these voices mirror and play off each other in different ways. And part of the fugue was a duet between two voices in which they almost seemed to be revolving around each other. And this reminded me of the dance that the two stars in a binary system, that they perform as they circle their common center of mass. Now, this got me thinking about stellar binaries, which are extremely common in the galaxy. More than half or so of sun-like stars were born in binary systems. And in particular, I was considering, one of the special properties of binary systems, which is the fact that they have enormous capture cross-sections. And what this means is that binary systems are far more efficient at gravitationally trapping unbound objects than a lone star. And what I realized was that a large captured cross-section could potentially help solve both formation of the Oort Cloud and also the origin of Planet 9. And that was a really exciting moment. And as I dug into both the physical and statistical details, it became more and more clear that a temporary, equal mass binary companion to the Sun was not only plausible, but it could actually be a considerably favorable model for both capturing Planet 9 and for forming the Oort Cloud.
Now, I have to ask you a question before we get deeper into this and the idea of primordial black holes and everything, as opposed to an actual Planet 9. Music. Now, you get ideas from music. So are there parallels between, one could say, the mathematics of music and the mathematics of the solar system? I mean, can you listen to Bach or play Bach and say, this reminds me of something?
Absolutely. I think, I'm very lucky to, be able to switch between music and science. Personally, it, in one sense, gives me sort of a different way of thinking and sort of a break from, they constitute reprieves from each other. But on the other hand, there are these incredible parallels. And, this fugue was one example, but also there's just a remarkable number of moments in music, either when I'm listening to it or playing it, which will strike a parallel in my mind to some sort of astrophysical phenomenon. And I think the reason for that is pretty simple. I think, composers were primarily, in a lot of settings, they were inspired by nature and the magnificence and wonder, but also the more puzzling aspects of nature, these things that maybe were difficult to explain in words. And I think that there's often a lot of similar feelings that come when considering space and the wonderful problems and puzzles that space affords us. And I think beyond sort of just sparking, specific ideas when I'm thinking about a problem or if something is at the back of my mind, I think the approach to music also sort of helps me become a better scientist because, in a similar way to astronomy, there's a pretty vast musical universe out there. Like if you wanted to try and play all the music written for piano, you would have a very difficult time. And not only that, but even if you consider a single composer like Bach, I mean, you could spend a lifetime working on one of his pieces. And so there is just so much richness and diversity, just like with astronomy. And so I think it sort of requires, to make progress in music and also in astronomy, I think it requires a certain amount of open-mindedness, I guess a combination of both curiosity about, this universe around you, whether it's physical or musical, and also of humility, sort of recognizing how small you are relative to everything around you, and not only that, but also recognizing how much is unknown, and sort of going in without or with as little bias as possible, and trying to put myself in that mindset. Sometimes it's easier when I'm doing science, sometimes it's easier when I'm doing music, but when I try to sort of be an observer, be a listener, in the practice of both of these fields, I think that helps me, greatly appreciate them.
Now, if you had to pick a composition throughout musical history that most reminds you of the solar system and the workings of it, and I must bar things like Gustav Holst and things that we all know about, but if you had to pick a composition from musical history that most reminds you of the solar system and really evokes that in your mind, what would it be?
Wow, that's a tough question. One that came to mind that I've been listening to lately, I think there are many that sort of touch on many different aspects, but in terms of thinking about the solar system specifically and the great degree of order in the solar system, but also the vast amounts of things that we don't know, and sort of, yes, there's lots and lots of interrelatedness and common origins within the solar system, and obviously a lot of interesting things in the solar system come down to fundamental sort of physical principles, which are by definition very orderly. But there's also some really sort of otherworldly things, and that sort of take your breath away in the solar system. And so if I had to choose right now, I would say the Goldberg Variations by Bach, because I think they share a lot of those properties that make studying the solar system and thinking about it so deeply gratifying.
The Goldberg Variations. This is, of course, deeply regular mathematical music. In fact, if you sit down on a harpsichord and play it, it's almost like running a sewing machine. But then you come across the chaos of the solar system, two bodies crashing into each other in the Oort Cloud, which is perhaps more like Domenico Scarlatti. So do you see sort of order in one type of music, like the order of Bach, versus the more dissonant disorder of another composer, maybe something in the 19th century, which is more indicative of the chaos that can occur in the solar system, if that makes sense?
Absolutely. I think that's exactly right. Even when I'm thinking about sort of catastrophic, events, whether it be a tidal disruption or, as you said, an impact, Prokofiev comes to mind, Stravinsky's Petrushka in particular, or Firebird. Even Berlioz' Symphonie Fantastique sort of, I think, captures this feeling of chaos on a larger scale. So yeah, I think that it's a wonderful source of inspiration, but also connection and parallel, as you mentioned.
Now, to break the strings of my inner harpsichord and go back to science, this idea of the sun having once had a companion. Now, there are stars known, a few, that are chemically similar enough to the star to be suspected of being from the birth cluster. Do we have any idea where an original solar companion that we might have captured Planet 9 from might be today?
Right. So as you mentioned, since the birth cluster was originally a cloud of gas, it makes sense that the sun, would have had many sort of siblings that were chemically similar, and potentially also similar in terms of mass and, of course, age. But the issue here is the fact that, of course, we don't see a current binary companion to the sun. And what this means is that it must have been lost. The binary must have been split. And this actually makes sense because if you have a binary in the birth cluster at the distance that we consider, which is to order of magnitude around 1,000 times the distance between the Earth and the Sun, would be the distance between the two stars, there is at least a 50% chance that in the birth cluster, a passing star, because it's such a turbulent, dense environment, would have ripped the binary apart, which of course is good news for our model, but it is also bad news for finding the star, because since then 4.5 billion years or so have passed, and that involves many, many revolutions around the galaxy. And so there's really no way to know or to even know where to look in the galaxy for this lost twin sun, because it simply could be anywhere.
About Planet 9, and we call it Planet 9 without ever having spotted it and only see evidence of it. But there is another possibility, a primordial black hole lurking in the outer solar system. Could you tell us about that?
Planet 9 is really exciting, and that's the reason why there's so many ongoing searches for it. These searches will be aided greatly once the Vera Rubin Observatory comes online, hopefully within the next year, because Planet 9, if it exists, we're not sure where on the sky it might be. And so this poses a problem for current telescopes, which by and large have pretty restricted fields of view. But the Vera Rubin Observatory will be able to scan the entire sky once every 3 days or so. And so this will allow for the sort of verification of Planet 9's existence, or we could be in a position where we don't see anything. And of course, the reason why we would expect to see a planet if it's out there, once we're able to see the entire sky at such a great depth, is because planets reflect light, and they reflect electromagnetic radiation more broadly. And so that's why, a telescope can be thought of as a direct electromagnetic search would be expected to find Planet 9. Now, the issue is, what if we don't see anything? What if the Vera Rubin Observatory operates for years and it has passed the point where we would expect to discover Planet 9 if it exists, and at the same time, the sort of evidence that has led to the proposal of Planet 9 in the first place, which is these asymmetries in the distribution trans-Neptunian objects, what if that persists and Planet 9 is still the best explanation? That would be a real tension. And Schultz and Unwin in 2019 proposed as a solution to that a somewhat out there idea, but a very, potentially exciting one, which is that Planet 9 could potentially be a black hole, since the likelihood of trapping a black hole could be comparable to that of trapping a free-floating planet. And of course, this black hole would be, planet mass. It would not be formed the same way as any black hole we've ever seen or, ever indirectly detected. But it is not out of the question.
What sort of, you say planet size. Now, this would obviously be a low mass black hole, which it's unclear how those could be, but say they are. Would this black hole be detectable? I mean, would material accreting into it give us any indication that it's actually there?
Exactly. So that was the question that was on my mind for a while, because, after this idea was proposed, there were various other proposals about ways to test this model, in the eventuality that down the line we don't detect Planet 9. How would we go about finding such a black hole? Because, one, it doesn't emit much electromagnetic radiation on its own, and two, it would be tiny. It would be 5 to 10 times the mass of the Earth, but it would just be the size of a grapefruit, which is just mind-boggling. But there were these proposals I had read that said, okay, well, maybe the best way to go about this is by using subrelativistic spacecraft and sending an array of sort of breakthrough starshot-esque gram-scale spacecraft into the outer solar system, and let's see if we get some unexpected gravitational pull, and then we'll be able to study that area in more detail. But there were various issues with that. One was cost. This would be a huge undertaking. But the other one is the fact that the interstellar medium, or ISM, would introduce a lot of noise that would actually likely dominate over any signal we might expect to get from a planet mass black hole. So I thought about exactly what you were asking, which is accretion onto this black hole, because we know, that is the one thing that black holes are sure to do. They suck in material, and as that material swirls inward, it emits radiation. So the black hole itself is not emitting radiation, but the material that it is attracting is sort of heating up and emitting radiation as a result of that. And this is related to the discussion about the Oort cloud, because at the distance of Planet 9, there would be a large number of comets and icy objects available to the black hole. Essentially, what would happen is that, the black hole is in the interstellar medium. You can think of it as, this grapefruit-sized object embedded in this gas, and this background gas, and the black hole would be accreting this gas, and that would create this gradient of both temperature and density. And so when these icy comets come somewhat close to the black hole, they start to feel the effects of this increased density and this increased temperature of this background gas, and that actually serves to melt and also break up these comets, and eventually the black hole rips apart the comet, and it essentially feeds into the accretion disk, which would actually be more of an accretion sphere in this case, and that would light up. And so I did the calculations, and it became clear that this is probably our best bet for finding a Planet 9 black hole, because unlike most black holes, which would emit in X-ray or radio or gamma ray, because of the size of this black hole, we would actually be able to see it in the optical light regime. And this is great news because, again, we don't have a clue where Planet 9 is. And if that is still the case a few years down the line, then we will simply be able to use LSST, the survey on the Vera Rubin Observatory that scans the sky constantly, and it will be able to search for these brief flares that would result from these catastrophic destruction of comets, and these flares would be in the optical. So the answer is, instead of spending billions of dollars, the best way to go about this might just be to hang tight and make sure that we're checking for these signals.
Now, the idea of a black hole, a grapefruit-sized black hole in the outer solar system affecting the Oort cloud, or an early stellar twin, either or, could these have disrupted the Oort cloud enough to create the bombardment of the early solar system? Could these things have diverted water, for example, from the outer solar system into the inner solar system and Earth? I mean, are these possible mechanisms for that?
Right, that's a great question. In terms of the solar binary, it is most likely that the binary companion was lost too early to cause major bombardments onto Earth. And in terms of the Planet 9 black hole, it's also difficult to say, but because, the tidal sort of effect scales with the inverse cube of distance, it seems unlikely to me that this could affect something so dramatic as a bombardment that would affect Earth. But that's not to say that the solar binary wouldn't have effects on the inner solar system. Actually, quite the opposite. For instance, the sun has a 6-degree tilt of its spin axis relative to the ecliptic plane. And one of the leading proposals for this, put forth by Konstantin Batygin, was that this could have potentially been imparted to the sun by passing stars that served to impart a torque. And this would have happened in the birth cluster, but alternatively, we can get the same effect from a solar binary companion. So that's one effect in the inner solar system. And Planet 9 also, there's fantastic modeling that's going on, but Planet 9 certainly had an effect on the evolution of the solar system, again, if it exists. And so this is definitely an active area of research.
Thanks for listening. I am futurist and science fiction author.
Wrong channel.
No, it's not. Thanks for listening. I am futurist and science fiction author John Michael Gauthier, currently hosting Event Horizon and wondering where Anna actually came from. One day I had a tablet computer, the next I had a boss. Very disturbing. And be sure...
And that's enough of that.
YouTuber forever! Like, subscribe, and hit the bell!
Sell out.
What?